Hello, my name is Brandon Clayton. I am the Algebra Guy, and today I want to talk to you about identifying multiples of a number. 2, 4, 6, 8, 3, 6, 9, 12. So hopefully you were able to finish that pattern. Those are called multiples. I want to talk to us about identifying multiples, and then hopefully in our next lesson we'll talk about divisibility. So by the end of this video, you'll be able to answer problems like this. Determine whether each of the given numbers is a multiple of 3, 645 and 10,519. Is 645 divisible? I'm sorry, a multiple of 3? If I kept counting 3, 6, 9, and so on, would I get to 645? Would that be one of the numbers? Same thing with 10,519. How would I do that? That seemed like it would take a long time to check, but I have a fast way to show you. Staying tuned, you will see. So the questions we want to answer today is, what does it mean to have a multiple of a number? And how can we find multiples of any number? As we saw in the introduction, these big numbers. So what are the patterns for multiples? 2, 5, 10, and 3. These are very common ones. 2, 5, 10, and 3. You could talk about multiples for 4, 6, 7, 8, 9. Those aren't as common. These are pretty basic. But if you stay tuned, I think I'm going to share a bonus for how you can find a multiple of 4 very quickly. All right, so let's define something first. What does it mean to have a multiple of a number? So a multiple of a number is the product of the number and the counting number. So the product of that number and the counting number. And I'm going to show you an example of what I mean by that. So a multiple of 3 would be the product of a counting number and 3. So it'd be 3 and another counting number times something, because that's the product. So 3. So 3, that number times another counting number 2, 6. And 3 times another counting number 3, 9. So you see that these are multiples because it's the product of that number plus another counting number. So it seems pretty straightforward. And it is. So just like I showed in the illustration, here's what it looked like if I were to continue that all the way through 6. 1 times 3, 2 times 3, 3 times 3. And all the numbers you see here to our right are multiples of 3. Because we're taking that one number, 3, and multiplying it by different counting numbers. And we're getting a product each time. So these are all multiples of 3. Now, I didn't have to go in order. I could have skipped to 20 times 3, and that'll give me 60. And the question is that a multiple of 3? Yes, it is. Because we took 3 and we multiplied it by some counting number and got 60. So now I know that 60 is a multiple of 3. So here's a bigger picture of many numbers so that you can see what the pattern looks like. How can we find the multiples of any number? So it's going to be the same way, right? So across this row here is the multiples of 2. 2, 4, 6, 8, 10, and so on. Notice that we have 2 times 1 is 2. 2 times 4 is 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. So we're going to have that same number being multiplied by another counting number each time to get a product. And you can do that for 7. 7 times 1 is 7. 7 times 2 is 14. 7, 14, 21, 28, 35, 42, 49, and so on are all multiples of 7. So that's how we can find multiples of any number, is take that number and multiply by any counting number that you can think of, and that is a multiple of that number. What are the patterns for the multiples of 2? So do you see the pattern for 2? Let's look at just this column. What patterns do you notice for all the answers for the multiples of 2? We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now, I tried to highlight it so you can see it, but do you see the pattern? All the ending numbers are either 0, 2, 4, 6, 8. And it just keeps repeating. 2, 4, 6, 8, 0. 2. So it's really easy to find the multiple of 2. You simply have to find the last number and ask yourself, is it a 0, 2, 4, 6, or 8? Pretty simple. So that's one quick way to find the multiple of 2. What about our next number, 5? How would I find the multiple of 5? What patterns can I recognize? Well, let's look at this one. 5, 10, 15, 20, 25, 30, 30. So you can notice that the ending digit is going to be a 5 or a 0. So if it has a 5 or a 0 at the last digit, this is so strong and consistent, you'll see that indeed it is a multiple of 5. Now, if it has an ending of 2, it can't be a multiple of 5. It's going to have to go in increments of 5, 5, 10, 15, 20, and so on. So that's how you would look for if it's for 5. What if it were 10? Look at the numbers now. We notice that the last digit is always ending in a 0. So there's going to be some overlap between multiples of 5 and 10 because we have 5, 10, 15, 20, 25, 30, 35, 40. So everywhere there's a 0, we have a multiple of 10. And for our last one, this is a pretty interesting one. What's the pattern with the 3? 3, 6, 9, 12, 15, 18, 21, 24, 27. This one may be a little bit tougher to see, but can you see it? For 3s, it's not that it needs to end in a certain number because look, 3, 6, 9, 2, 5, 8, 1, 4, 7. We really don't see a pattern there. But what you will notice is if you can add up all the digits and you get a multiple of 3, then it's a multiple of 3. So in this case, 1 plus 2 equals 3. And is 3 a multiple of 3? It sure is. Of course it is. 1 plus 5 is 6. Is 6 a multiple of 3? Yep, right here. 3 times 2 is 6. 8 plus 1 is 9. Is 9 a multiple of 3? Yep, it's right here. So I know 18 is. And so on and so forth, even going down to 27. 7 plus 2 is 9. Well, I know 9 is a multiple of 3, so this must be a multiple of 3. Because 3 times 9 gives me 27. So isn't that a cool way to identify if you have a multiple or not simply by knowing these patterns, especially for 3 because it's not as intuitive when you glance at it. So let's see if we can practice a little bit. Let's determine whether each of the following is a multiple of 2. Well, in order to be a multiple of 2, remember that we have to have the last number be equal to what? It has to be equal to 0, 2, 4, 6, or 8. Do I have an ending on this number that's one of those? No, I don't. So I'm going to have to say, determine, is this a multiple of 2? We're going to have to say, no, it is not. And for this piece here, we're going to look at the last number because we're looking for a multiple of 2. Does it have an ending of 0, 2, 4, 6, or 8? And the clear answer is yes. There's a 4 right there. So I know that it's an even number, in this case, a multiple of 2. So we're going to say yes. And it's that simple. Knowing those rules helps out tremendously. What about this one? Multiple of 5. Is this one a multiple of 5? Well, what do we remember about the endings of our multiples of 5? They all end in 5 or 0. 5 or 0. 5, 10, 15, 20. So if I kept going like this, it'd be easy to write out, right? 5, 10, 15, 20, 25. Because they all end in 5 or 0. So this does not end in a 0, so we're going to have to say no. Is not a multiple of 5. This one, however, does end in 0, so we can say yes. Just by glancing that quickly, think about how cool that is. We didn't have to count all the way up to 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and all the way up there to C. We can just know there's a pattern, and this is what's beautiful about math, particularly as we get to algebra, is that it's all about looking for patterns. It makes our life so much easier. All right, let's do this one as well. Is this a multiple of 10? Well, if we remember our rules from multiple of 10, 10, 20, 30, and so on, what do they have in common? They all end in 0. This one does not end in 0, so it's not a multiple of 10. This one does end in 0, so I know for sure that's a multiple of 10. Matter of fact, 35 times 10 will give me 350. So, easy peasy. When you understand the rules, it's really great to be able to just simply glance and get that idea. Now, what about multiple of 3? Do you remember the rule for remembering the pattern of how to see if it's a multiple of 3? Well, we had 18, and I said just try 1 plus 8. And that gave us 9. I shouldn't say this is equal to. But 1 plus 8 is 9. So if when I add up all the digits in that number and it gives me a multiple of 3, then it's a multiple of 3. So let's add all these up. 6 plus 4 plus 5. 6 plus 4 is 10. 10 plus 5 is 15. Is 15 a multiple of 3? It sure is, because 3, 6, 9, 12, 15. 3 times 5 is 15. So I know that this whole thing is a multiple of 3. What about this? This ends in a 9, so that looks good, but does it all add up to 15? So 1 plus 0, add up to a multiple of 3. Let's check and see. 1 plus 0 is 1. 1 plus 5 is 6. 6 plus 1 is 7. 7 plus 9 is 16. Is 16 a multiple of 3? Let's think about it. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. 3 times 6 is 18. So I'm looking for a 16 here, but I don't have it. It should be somewhere in between 5 and 6. So no, I can't multiply a counting number to get 16. So I'm going to say no, this is not a multiple of 3. And that would do it for this particular lesson. Did we cover all our questions? What does it mean to have a multiple of a number? Yes, we talked about that. Multiple of a number is just 3, 6, 9, 12, and so on. Taking that number and multiplying by any counting number. How can we find multiples of any number? I just said so. And what are the patterns for multiples of 2, 5, 10, and 3? And we just saw those patterns. 2s have 0, 2, 4, 6, 8. 5 has 5 and zeros. 10 have just zeros, and 3s, the sum of all their individual digits, will add up to a multiple of 3. Guys, thanks for tuning in again. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.